Coming up on this episode of the IoT Inc. Business Show.
IoT, I think in the future, will influence AI considerably, even more than the other way around. The reason for that is currently most of the AI systems are more like point-in-time systems. What IoT is doing, the sensors are coming in first, but then the system is built a model based on those sensors because it has got more information.
When talking AI and IoT, what we're really talking about is machine learning in IoT. And the one thing machine learning needs above all else is data. Lots and lots of data. Structured IoT data, when piped in properly, can be transformed and loaded efficiently for machine learning to create beautiful and, more importantly, accurate models. In this episode of the IoT Show, I speak with Anand Rao about the symbiotic relationship between AI and IoT.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is Dr. Anand Rao. Anand is the Global Artificial Intelligence Lead for PwC. He has over 30 years of experience in building advanced analytics and artificial intelligence systems and advising clients on digital and AI strategies, customer experience, marketing, and operations. Anand, welcome to the show.
Great to be here, Bruce. Thank you.
So what is your PhD in?
Yeah, my PhD was in artificial intelligence.
Okay. I guess I should have expected that.
Way back in the 1985 to 88, so goes back a long time.
And why did you choose, that's the thing. AI has been around for almost, 40 years or something like that, or maybe even a little bit longer, 50 years. Why did you choose artificial intelligence for your PhD?
Yeah, no, AI has been around, as you said, for more than 62 years.
Yeah, I guess. Yeah, right.
Is when the word was coined. Mm-hmm. And the reason I chose AI was I did my undergrad in computer science, and I was obviously looking for leading edge, cutting edge at that time. Right. And AI was on its upswing. And again, AI has gone through multiple upswings and downswings and springs and winters, as they call it.
That's right. AI winter, I think I heard that, right?
Yeah, that's right. Yeah, so we are gone through 2 AI winters and we are on the 3rd AI spring. And so through one of those AI springs, I made the decision to do my AI PhD and actually worked in AI for almost 10, 12 years after that. So I spent quite some time in that. More, I would say, those days it was more aerospace, defense, NASA, those kinds of projects. And now, of course, it's sort of very much on the business side of things.
Yeah, no, and that's what we're going to talk about. Now, just out of curiosity, when you said you were working in AI, what is it that you were actually doing?
So we were actually building what we called as real-time systems. Let me just give you an example. Okay. Mm-hmm. And for the military, for the Air Force, both in US as well as in Australia, we were building systems where the AI was working side by side with a Top Gun pilot, if you like. So the idea was just as a Top Gun pilot is in a simulated environment doing all the different maneuvers, it's not just one person. They basically fly in huge squadrons of 8, 16, 32, and so on. And you want all of your other pilots also to be intelligent entities. And you couldn't get 32 Top Gun pilots all on dome simulators at the same time. So the idea was to create these intelligent pilots which could work side by side with the real pilot.
Okay. And so it was mostly then, I guess, for training purposes then?
Yes. Yeah. This was very much for training purposes. We built something similar for air traffic management for the Sydney airport. So there's, again, another example of AI acting as a decision support engine for air traffic control people.
Now, did 32 planes, do they ever actually have 32 Top Guns flying planes at the same time? Like in formation, or how does that work?
Yes, they're all in formation. Yeah, they do.
32?
They do.
Gosh, never knew that.
Yeah, they go, obviously in pairs, they go 2, 4, 8, 16, 32 kind of formations. And what is interesting about this is you need to build, obviously, thinking machines or intelligent agents which can react within a very short time frame, so real-time situation. And interestingly, Top Gun pilots think through almost 3 or 4 nested evaluations. So I might think that my opposing pilot is thinking that I will do this, therefore I'll try and fool him to do Y, right? So they go through 3 such nested things all within fraction of a second.
And they're doing that to evade, or what do you?
Yes.
Why? Okay.
To evade, so that you get one up on your opponent.
I see.
The more nested they are, the more difficult it is for the other one to really pick up on what you're doing.
This almost sounds like an AI game of chess, or now more like Go. Is that kind of how it works? It looked ahead and then kind of chose the optimal solution given the circumstances?
Yeah, that's right. Yeah, that's exactly right.
Oh, interesting.
So we were building digital twins where the digital twins were of Top Gun pilots.
Yes, exactly. No, that's interesting. And Top Gun pilots and Top Gun pilot opponents as well, right?
Yeah. Yes, exactly. Yeah.
Now, how did you train it? How did you train these Top Gun opponents? Was it through observation, or was it just common sense? How did that happen?
Yeah. So the military has sort of very, very detailed strategies and what they call as standard operating procedures, both for whichever country you are, but also the opposing teams. So what they call as the red and blue teams.
Yes.
And they have very elaborate strategies that they can test and evaluate. So it's a very interesting test bed for doing this type of role-playing games, digital twins, and so on. Yeah. And so this is way back in the 90s, they had a very sophisticated API layer, if you like, in today's terminology, to go from single individuals or individual aircraft all the way to a complete wargaming scenario.
Yeah.
And again, systems built by different people, different simulations, but they could connect it all in one massive digital wargaming, if you like.
Yeah, and that's interesting because I have a bit of background in that as well. When I got out of the entertainment, so digital authoring tools for movies and games and so forth, I went to a startup actually in the Silicon Valley, and that's what they did. They did modeling and simulation for individual models, but then, as you're saying, then also putting them in. I'm trying now to remember the terminology. The reason I did it is because I was looking to OEM the technology for the game industry, and the the terminology was different. But it's kind of ironic because I don't know if it's ironic, but it's interesting now because fast forward X number of years, and I don't know when the two curves crossed. But the military was then actually looking at the game industry as opposed to the other way around.
That's right, yeah.
Yeah. And so 20 years on now, are they still, are you familiar with, has this evolved? Are they still using the same techniques for their Top Gun pilots?
Yeah, I think the techniques have evolved substantially. So now you have all the AR, VR technology, as well as all of the sort of the intelligent technology that we are working on. And of course, the military has gone much further in terms of the kinds of things that they are experimenting with, including, I guess, the brain-machine interfaces and so on. So I think there's sort of quite a number of interesting things that the defense agencies are doing, which are also translating very much into commercial areas. So one of those is what DARPA has launched as Explainable AI. And that's something that we have found very, very useful for our commercial clients in various areas. So trying to build AI systems that can explain to a lay person. And so very much into that domain now.
Can you just give our listeners just a little bit of an explanation of can you explain what explainable AI is to our listeners, please?
Yeah, sure. Yeah, I can do that. So one of the challenges I think we have as an industry in AI is as AI gets more into mainstream business decision making. So you have a lot of financial services companies, banks, insurance companies, retail companies, healthcare, all of them using some kind of AI to make certain decisions, whether it's financial decisions, health decisions. When these decisions are being made by AI systems, let me be more specific here. So let's say machine learning systems, then trying to show that the machine learning is doing things in the right way. When I say the right way, it is not biased in any sense based on the data that it has been fed. The algorithm or the recommendation it comes up with is something that it can explain, or it can explain in a way that a common person can understand. Those are all becoming very important if we as a society can trust these machine learning systems. So, for example, if the AI comes and says, I've been denied a mortgage, but you have been granted a mortgage, and if I ask why, if it says your score is less than 322, and that's why you didn't make it, that's not an adequate explanation. I would like to know what is the cutoff score and how do I build that score? And I need something more tangible as an explanation. And now we have various regulations, especially in EU, which are coming up, which are demanding that when people implement these kinds of systems, also have an explanation that is understandable. That's just one example of explainable AI, where you want to explain the logic. Again, based on the algorithm of machine learning, some are easier to explain, some are more difficult to explain. Systems around deep learning are more challenging to explain what the system is doing, and there's a lot of work and research going on to try and take a neural net or a deep neural net and then try and explain what exactly it's doing in a way that people can understand.
Yeah, so for everyone listening, what Anand is referring to, the deep learning or the neural nets, is there's something called a hidden layer, right? And it could be multiple layers. And I think the mystery is mostly, am I correct to assume the mystery is mostly in those hidden layers?
Yeah, that is right. So what happens in these sort of deep neural nets, they are literally like the brain having billions of neurons connected with each other. What you have in these systems, each neuron is mimicked by, if you like, a single node receiving multiple input, and based on the weight of those inputs, it generates an output. And this can be connected, obviously, in multiple ways and multiple layers. And all that the deep learning system is doing, it is receiving that input layer by layer. The first layer, if you take an image, for example, the first layer recognizes various lines and curves. The second layer might pull some of those shapes of the different curves together and might start detecting, if you like, an eyebrow. And the third layer might look at an eye with an eyebrow and an eye. And the fourth layer might pull the two eyes together and say that's sort of two eyes with a nose. And then finally, the layer might say this is an image of a person whose name happens to be Bruce based on my comparison with all the other images that I have seen. So it layer by layer, it essentially creates a recognition of you as a person. And so that's what's happening in a deep neural net. And being able to explain why the picture that it's seeing is Bruce and not Anand, for example, are the kinds of explanations that we need. Or if we take your picture, but let's say it was 10 years back when you looked much younger, Bruce, then how did it actually know that it was the same person? Even though it looks slightly different, it can still recognize you from a 10-year back photograph. Then can it explain why it's the same?
Yeah. And, I thought about this a little bit, and I'm happy I have you on the line to ask you a little bit more details. But I think you gave a really good explanation. There's these nodes, and the nodes are doing something, let's call it some statistical, and it could be very simple. It could be it could be complicated, but some statistical calculation. So and it has weights, like you said. So each one's weights, and these weights change as it learns. I think correct me if I'm wrong. Right. So, okay, now, there might be a lot of them, but you could document them. So you could document the weights, and you know how the statistical functions work. So the only thing I can really come up with, and this is what I'm asking you indirectly, is the only reason we couldn't maybe understand why it's making the decisions is with the random number generators, or is it something else? Because everything else is pretty known. Like, what is different? Like, why wouldn't we be able to explain? It's like I know it might take a lot. It might be, thousands and thousands, but we can say this is the weight, this is a statistical function, and it should be reproducible, like a trace, if you're tracing through a program. But the only thing I can think about is the only thing that's not reproducible is with random number generators, and then you can't generate the same number.
The challenge, it's sort of twofold, the challenges. So in one sense, it is, you're right, it's basically weights and connections, but there are literally hundreds and millions of these connections. So trying to explain to someone that the reason why we recognize this person to be Bruce is because in this particular node, the weight was 0.65 and it triggered this one. And in this other layer, it was 0.56 and it triggered this other recognition unit. That doesn't really help a common person. Okay. So that is one of the challenges. And again, you can take the image, which is a sort of a common use of deep neural nets, but we have been using it for audio, for natural language, and so on. So it gets harder as you start looking at some of those. So that's one challenge, right? Okay. So there are literally hundreds and thousands of numbers, and how do you abstract from that is one challenge. The second challenge is, again, based on just the algorithm and how it is doing, how the deep neural net is sort of identifying objects. It can easily get fooled by pictures that look very similar. And there have been a number of cases in the literature where people have shown it can recognize a certain type of a dog, but then you put a muffin. That muffin sort of looks like a dog, but
with the raisins on the top, right?
Yeah, with the raisins on the top, and again, the human eye catches it, but even for the human eye, it takes a few seconds. And say, oh yeah, no, that's not really a dog. So you can easily fool it in certain cases. So that's also puts more of an onus on how the systems can explain themselves. And then now we are getting to another third layer of complication where people are looking at the weights, and you can literally engineer the system to get the recognition wrong. by just inserting a few pixels, which are probably not even visible to our naked eye, but can be seen or can be processed by the system and can recognize something opposite or something other than what it is. And that could be very dangerous as we start using some of these systems for obviously object recognition, autonomous vehicles, and so on. We need that robustness, and we don't want people hacking into it and inserting a few pixels and getting that algorithm totally off track in terms of what it's recognizing. So that's becoming a bigger issue as well.
Okay. So, the concept of it being fooled, and I saw something. It was funny because I was at a conference yesterday, and I think I know the one you're referring to. It was a Chihuahua, and then it was a muffin. I think, and it had like
yeah,
I don't know, it was
that's
chocolate
right. Yeah,
chips
that's the one that I'm referring to.
Yeah. And it was really funny. Yeah, it was really difficult to see, but I can understand. Okay, so it's getting fooled. But you should still be able to debug it, though, right? I mean, it's one thing. There's the accuracy issue, and then there's the reproducibility issue,
yes.
And so I think what you're saying is that it's just so complex that it's difficult to explain to a layperson how these decisions happen. But it could be explained. Is that right? I mean, if you did lay out the thousands and because even with a random number generator, if you use the same seed, then you should be able to get to the same place. So it's just a complexity, I think, is what you're saying then?
Yeah, exactly. Yeah, and also making sure that when people are introducing these things, especially in production version, as long as we are experimenting, I think that's fine. But if you are putting it in production version, you give enough of an explanation. Whether it is mortgages or whatever insurance or even scanned images for diagnostics, we give enough information as to why this is the case and why not the case, right? So the classic example that DARPA uses is when it's not enough if you just recognize something is a cat, but you might also want an explanation as to why is it not a dog? Why did you come up? What were the sort of the salient features which made you say that it was a cat and maybe not a tiger, which obviously is also another form of cat, or a dog, which has different features, right? So I think as humans, we want that kind of an explanation. In some cases, we may not. But in many cases, we would want that explanation. So that's why that focus on explainability
is important. Yeah, and so DARPA's leading the charge, or at least one of the leaders in this area of being able to explain the AI. And I didn't realize. So I heard regulations, but I didn't know it was in particular a European. More of a European thing. Is that accurate, or is it pretty much worldwide, these regulations that you're referring to?
Currently it's pretty much European where they have this notion of explanation, but it's also becoming best practice for everyone. So for clients, especially in healthcare and financial services and other areas, especially some of the regulated areas, they're somewhat more careful in trying to explain those.
Yeah. That makes sense. Okay, well, I didn't mean to jump down too deep, but but why don't we go up high? Let's start at maybe some more at a basic level. But I'd like to hear your thoughts on how to differentiate AI, and we can even take it down to machine learning if you want. But AI and analytics. What are your thoughts there? Why are they different? Because I see, this is the thing when something gets hyped up. You have so many, let's say, less qualified people writing about the topic, and they seem to be using the two terms interchangeably. And I just want for everyone listening just to understand, get an understanding of, how you see the difference between the two.
Yeah, no, it's a good question, and I agree that there's a lot of confusion in the market and various terminologies. At least the way I see it, or we see it here, is that it is very much a continuum. In terms of how things are used. So I would start with data analytics, advanced analytics, automation, AI, all on that sort of spectrum. And what I mean by that is on the analytics side, so obviously you need the data and you're sort of making sense of that data. And the analytics, typically people talk about diagnostic descriptive analytics first, and then the diagnostic analytics. Both are backward-looking, what happened, kind of analytics. And then you start looking at predictive models, so which is sort of more into the future, and then prescriptive models, not just sort of predicting, but also making specific recommendations and being more prescriptive. And that spectrum sort of continues, in my view, where you're not only doing prescriptive analytics, you're doing adaptive analytics. So something that's sort of continuously changing as the environment changes. As you go through the spectrum, you're finding that you're using more and more advanced analytic techniques and also various types of unstructured data. As you use more unstructured data and as you get into more of the advanced analytics, at some point it just gets called AI.
Okay.
That's the way I would view it, right? So, for example, as we start looking at natural language text and then taking any kind of Word document, a PDF document, or any kind of a social media document, you're trying to understand the sentence structure, you're finding keywords first, but then trying to understand the meaning of sentences, even synthesizing summarizing the paragraphs and even entire papers. All of that involves natural language, but you're using analytics or natural language processing now. So people get more specific on natural language processing, natural language generation, and so on. And that tends to be very much the forte of AI. Same thing with images, right? So we have always used structured information, lots of data, big data, and so on. But now we get into the image side, and now it's all a matter of pixels. And how do you take an image, just a sort of a static image, and then you can move on from there to video images as well, and then say, can I recognize objects here? What kinds of objects? Again, to our just previous conversation, can I recognize a cat from a dog, or can I recognize Bruce as of now versus 10 years back, and so on? All of those things require deep neural nets, for example, and that again is considered AI. So I think the line between advanced analytics and AI, to me, it's essentially at a spectrum. And as we get into more unstructured data, i.e. natural language, image, audio, then it tends to be more AI. And that's one view, more from an analytics perspective. The other way to also think about AI as a definition, again, as we said, AI has been around for 60 plus years, 62 years. The way AI has been defined from the early days is any computer system that can sense, think, and act in an environment to satisfy a specific goal or objective is considered AI. So now when you talk about sensing, so typically the sensing has been through a computer language, but now we can communicate with the computers using natural language text, right? So we can basically take a document and give it to it, and then it can understand. We can speak to it, right? So again, all the voice recognition, speech synthesis, that's happening. It can hear us, and it can also speak back at us based on all the information. So that's how we are getting into sensing. And now, if you have a camera attached, the camera can look at me now here in my office space and say that there is a desk and there's a phone there, there's a laptop there. It's not only seeing the image, but it is describing that image just as any human would. So the sensing ability have come a long way in the past, literally 10 years or so, with all the sort of the recent advances. So that's the sensing part. When you get to thinking, people talk about it in terms of machine learning, problem solving, deep learning. All of those things are various components of thinking. How do you identify objects, and how do you make inferences or reasoning? All of that goes into the thinking bucket. And then you have the acting bucket, where you have made those recommendations, but you are effecting some change in the environment. It could be physical, or it could be a digital environment. So process automation or robotic process automation, intelligent automation, where the system is automatically taking a certain action. So sending an email or making a transaction on your CRM system, all of that the system is making automatically. So that's acting. Of course, you can have a physical robot acting as well, but you could also have actions in the digital world. So if you combine all of that, that's basically an umbrella for AI. Sensing, thinking, and acting, and then you have all these areas: natural language processing, machine learning, deep learning, digital twins, and sensor-based reasoning. All of those come under this broad umbrella of AI.
Yeah, no, that makes sense. And if we now, and I want to talk to you about, obviously with your report, and we want to talk about how AI and IoT come together, and just, using your definition there, sense, think, act. The sense and the acting, yeah, that's definitely in the realm of IoT. But I want to go back, so it's interesting. I like your definition of that continuum, because, sometimes people describe predictive, let's say predictive maintenance or predictive analytics is really what it is. Sometimes they define that as AI, and sometimes they define it as analytics. And so you're saying kind of, which makes sense, is, it just depends. I mean, it could be thought of in both ways, but when you're at the end there, when you're at the adaptive, and adaptive now we get into we get into deep learning, and we get into neural nets. Then I don't think there's any discussion there. But that's interesting, because prescriptive analytics is also something, it's what should we do as opposed to what's going to happen, or what should happen, and sometimes that's described as analytics as well. So so you're saying there's no real hard force rule, but and then the other way that you're talking, and then this kind of opposes a little bit, because going from structured to unstructured, because often if you think about, at least the internal data sources of IoT, they're going to be time-based. And so they're going to be very much structured if it's coming from sensors. However, IoT can also tap into other forms of external data that may be unstructured. And so, So why don't we move that? Let's shift then into IoT, and maybe continue what you're talking about here. And what are the areas in AI that are, applicable to IoT, or why is IoT and AI a good match? Maybe just sort of now bring the two worlds together for us.
Yeah. So there are actually sort of two very important connections between IoT and AI. People often talk more about how AI can be used in IoT. Let me handle that first.
Okay.
And then come back to how can IoT change the way we view AI, which I think is even more powerful thing.
Okay.
So the first one, again, you're absolutely right. So one of the things that's sort of happening in the IoT world is anything that is physical is being digitized, right?
Yes.
So anything, Internet of Things and Industrial Internet of Things, so anything which is out there, which physically exists, can be digitized, and it's sort of sending some information back. So in that
using
sense,
a digital twin, for example.
Digital twin, for example. That's right. Yeah, exactly. So there are lots of these sensors. So IoT is everything about sensors, and now the way, and it's not only sensing, obviously it is affecting certain things as well, right? So very simple thermostat, and then it sort of changes the temperature, actuation, right? So it has both that, very much that sense component that we talked about, and the act component that we talked about. The in-between think component is there. It may be, again, it might happen at the edge level, and depending on the speed of computation, the amount of data, you might have a very thin layer of that think, or you might have a much thicker layer of that think. So the role of AI, in my view, in IoT is very much that thinking component.
Yes.
Whether it happens, it could happen at the edge, but it also could happen at not at the edge, but at some arbitrary node above the edge. You're collecting all of this information, and then at some point you're making sense of it. So let me give you a more concrete example of this. So we have been working with the airline, And airline companies, there are literally hundreds and thousands of sensors in any aircraft with all of the instrumentation. The engine-related data go to the two large engine manufacturers, so the airlines don't see it. But anything other than the engine data all comes back to the airline. Now, one of the big challenges this airline had was trying to figure out when aircraft lands as to, at any point in time, there are lots of alarms that are generated while the system is in the air. Mm-hmm. And when it comes down, they want to determine very quickly before it takes off again as to what were these alarms, were these alarms anything serious coming through from all the sensors, and is there some part that needs to be replaced before it can again take off in the next hour or so, right? So basically they wanted to risk rate the alarms that were coming so that you can determine whether a particular part needs to be replaced right now before the flight can take off, or is that not that critical but can be replaced within the week or so, or it's something that can be taken care of in a monthly schedule, or everything is fine, right? So basically 4 risk classes is what they wanted to do. And I mean, of course, people are doing that today, but it's a very manual process. So as soon as the aircraft comes in, so you have all these sort of engineers sort of pouring through the data and then very quickly determining. So what we did, so this is where the AI comes in, is essentially took in all of that data, the sensor data, and using the sensor data, essentially correlating all of the different alarms so that you can start piecing together the root cause for a particular alarm to go off, right? So once you have done that, then you are essentially risk rating them. And what we did with this particular airline company is used the wealth of data that their engineers already had in terms of their diagnosis. So taking the diagnosis of what the people had done in the past, along with what we could determine from the sensors, we combined the two and essentially create an automated predictive maintenance tool so that as soon as the aircraft comes in, you download the data, and then it is making those assessment on the various alarms in the various parts. And then the engineers are looking or using that as an aid to do it much faster. And of course, this is around predictive maintenance. So the first thing is to essentially assess the risk of the different parts. But then you can definitely imagine from here how they could do the various analysis around what kinds of parts are failing more often. Where should they have the inventory? How can they minimize that inventory? So that's sort of the second level at the airline company. But then now you can go even further and say, hey, but for this particular aircraft model, this particular part seems to fail after 100,000 miles of flight. Whereas for this other aircraft, it goes on for at least 300,000 miles, right? So there's some defect back to the manufacturer, right? So you have layers of analytics that can be built starting from this sensor data. Right, so that's what is, again, this is for aircrafts. You can imagine doing this for cars, which obviously a lot of people are doing. You can imagine doing this for manufacturing units, almost any kind of a physical environment, you can start doing this.
No, and I like this one, and I want to dissect it a little bit because I think it maybe does give a good illustration between AI and analytics. And so, if I'm to understand, what you're saying correctly is interesting because I think what you're saying is, we have all this data and the data is from the past and all these lights have come on, these different combination of warning lights have come on. And then the data that we have is, of course, which lights came on, but then also what the actions were that were taken by the human.
Yeah.
And I think what you're saying is then you're applying machine learning to then look at all those, those situations and then learn from the humans. So this is by definition machine learning. Now, I like that because this is almost like a meta predictive maintenance because you could also then look at the part level and I think you could do predictive maintenance on that in an analytical fashion.
That's right.
Where it's just strictly analytics, and we can then look at a failure signature, match a failure signature, and then make, some sort of prediction. So I think this is a great way, for everyone listening now to think about this is there's kind of this, it's learning, it's machine learning. And that also, by the way, is on your spectrum at the very end, in the adaptive analytics, where, a big part of machine learning is that it's, you were talking about the different layers and the different nodes, and it's continuously changing and adapting to try to learn, to try to get better. So is that an accurate way of describing it?
That's a very accurate way. Yeah. And based on it's making some recommendations, the recommendations might be overridden by the people. So then the system can learn about that. It's again making certain predictions. And let's say that it doesn't pan out. Let's say it says, this can wait for a month. And then 2 flights later, the alarm comes back again. Then it is sort of correcting its mistake and says, okay, I thought this particular situation was okay, and I risk rated it as a sort of a monthly replacement. But given that this fault has happened thrice in the past week, we should take it down. Right. So it's making those. So that's where it truly becomes adaptive. Right. So it's sort of making prediction, and then it's correcting its prediction if it goes wrong.
Okay, I see what you're saying. So it makes the initial predictions from learning from what the humans did, and then it has a model, and then it applies that model to then moving forward, and then it adapts that model according to how it performs, how it actually performed on making those decisions.
Yeah. That's exactly right. So that's what sort of is giving that power. And that's where I see, AI and IoT coming together. Now, I also mentioned when you asked the question that there is also a more interesting case where IoT, I think in the future, will influence AI considerably, even more than the other way around. So the reason for that is currently, most of the AI systems are more like point-in-time systems, and they are basically using the information, knowledge that we have collected to date. Now, just as I mentioned in the previous case, the adaptive case, where the sensors are coming in first, but then the system has built a model based on those sensors, and it has a chance to correct it 2 days from the current point because it has got more information. So what IoT is doing, it is essentially putting sensors literally on the entire planet. Now, AI so far has been pretty static, and we're almost in the stone age of AI.
It's like a snapshot almost, right? I mean, it's kind of what you're saying.
We are not really using all of the information that is needed. Now, you can imagine a world 10 years from now, 20 years from now, where everything is instrumented. Then the AI knows, let's just take a city, for example. It knows exactly how many vehicles are coming into Chicago from the various roads, right? So it knows all of that information. It can, today, it can say what are the traffic routes that you should take to minimize your travel. And that's something that can happen very dynamically. As an accident happens, it can start rerouting the traffic. It starts telling people where best to cross the thing, or which train to pick up, because it knows the schedule of all the trains, for example, right? So as you start getting more and more information about almost anything in a city, then the AI becomes very powerful and very adaptive. That's just one example. I just sort of took a city example, but that's where I see for AI to become truly adaptive and truly learning continuously, IoT almost becomes a critical element. So once you have all of that digitized data flowing into the AI, then the AI becomes far more powerful and continuous learning, as opposed to just sort of one-shot learning as it's doing now.
Yeah, no, that makes sense to me, and it makes sense to me also in this, in this differentiation with analytics, which I'll sort of bounce off of you. I'm often asked by clients or anybody, what's the difference between an IoT model and a regular model, and one of the things I say is it's a living model, and it goes to your point that there's continuous data that's coming in and to update the models. However, this is the reason it's what you're pointing out is the reason it's so well suited to AI is because, and then I think we should scratch AI and say machine learning, but because it's so well suited to machine learning, it's because its continuous source of data can update the model. You can do that with predictive analytics as well, but the framework is difficult because a predictive analytics is happening, just like you say, kind of like where AI is now. It's happening now. You construct it, you make a decision. And, and this also goes to the difference between, let's say, a predictive, the structure of a predictive analytics system and an AI system. It's kind of like, they're kind of using the same statistics. However, the AI is kind of a system that does this. It's a loop. It's an iterative system. And so to me, that kind of does two things. It brings your point of why it's so well suited because it's a living model. So there's continuous data. So we can keep on learning. We can keep on making it better. And it also differentiates for me, which maybe was or was not intended by you, because that is also a difference between a AI, let's call it a machine learning statistical model, and a predictive and an analytical statistical model, because the framework allows for this. Even though the underlying math is the same, the framework allows for this iteration.
Yeah.
Is that accurate?
Yeah, that's accurate. Yeah, that's accurate. So there's a type of machine learning that goes by the name of reinforcement learning. And that is very much around taking those environmental cues and then modifying what you are doing. So that's what's sort of happening with IoT. You're getting the entire world is sort of digitized or sensor enabled. So you're getting that data back and you are learning from that reinforcement. And that's what makes it very powerful, as you said.
Yeah, no, okay. No, that I think this is helpful, to kind of structure, because at first I was getting hung up, and I'm sure, others listening are probably in the same situation. I was getting hung up on saying, what's the difference here? It's the same statistical techniques and the same math. But then it was like, okay, a little bit further. Okay, now I understand it's really like code that goes around the math in a sense.
Yeah,
and
that's right.
These systems. And now when you say it this way, yeah, it does. And so going both ways, just to kind of repeat what you were saying, or to summarize what you're saying, AI and IoT is great because IoT does a fantastic job in sensing and acting or actuating, but the thinking part then can be taken, can be done by AI. And then the other way is that it's going to be the data. It's going to be lots and lots of data, and I think we're talking mostly about structured data, or is it beyond structured data?
It could be beyond structured data. It could be structured data as well that it is taking in. Yeah.
Okay. Well, let's pop up a little bit more, and let's try to take it to business. And I guess I want to talk about competitive advantages. I know this is something in your report, and maybe you can just walk us through. Starting, what are the competitive advantages of using IoT and AI versus just IoT?
Yeah. So one of the things that we talk about here is various ways in which I guess IoT and AI are giving advantage to companies. So myself and along with a couple of our colleagues, John Swiokla and Miles Everson, they've written something around the 6 types of capital. And so 3 types of capital are very traditional. So these are things like financial capital, human capital, and natural resource capital. So those are all people have used those to build competitive advantage. But in the digital world, we are talking about network capital, network effects, if you like, behavioral capital, and cognitive capital. So these 3 become more important as we think through both AI and IoT. So now let's just sort of try and piece these together, right? So now if you look at IoT, as we just said, there's sort of literally hundreds and thousands of sensors, and they're all connected in some way. So the whole network effect is happening with the sensors, where we not only know the individual sensors, but the entire network of those connections. So giving us that network effect.
And even just the total number, right? I mean, it's even if it wasn't even the networking, it's just, simply just the number that there are that are connected that give you that network effect.
And as things get more connected, there is this sort of obvious advantage of being on the net, right? So just like social networks that has been happening for the past, 10, 15 years, now we are getting the network effects on IoT, where the more things get connected, the better it is. So more devices get connected, the more data you have, and you can infer more. So you want to put more devices on the network, IoT on the network. Right? So there's a network effect there. Then all of this network effect, what it's really trying to get at from an IoT sense is the behavior of the people, the behavior of the systems, of the hardware, of the assets that everything is wired on. So it's all about the behavior, right? So the aircraft example, it is when is something functioning normally versus functioning abnormally. So that's the behavior of an aircraft. It's the behavior of the tail or the wheels, right? So for each one, there is a specific behavior that can be understood. So that's the behavioral capital.
Now, so you're saying then, just to stop you there, you're saying then this understanding the behavior either of people, but let's bring it into things for IoT, is capital, and that capital is used, it provides this competitive advantage.
Yeah.
Is that what you're saying?
Yeah, that's exactly what I'm saying, right? So again, back to the same example. Now, as an airline, right? So as an airline, now I have a lot more behavioral data on all the components that went into a specific flight. And I can now start saying what is the behavior of various parts, various types of aircraft, models of aircraft, and so on, so that I can start thinking better in terms of my fleet management, in terms of my inventory management, right? So that's at that level, the behavior of the aircraft. Now, as an aircraft manufacturer, right? So if you go back one more level up the chain, now the same behavior could be very useful for the aircraft manufacturer to say, Model X, these parts were going on for 200,000 miles of flight, whereas in Model Y, it seems to be failing with just 100,000 miles, right? So who was the manufacturer? So you're looking at behaviors one more level higher in abstraction. So it's all of that behavioral data, and that gives you a competitive advantage against your peers and competitors there.
Yeah, and I think, so to bring it into the AI again, number 4 being the network effect, why AI makes sense in IoT is because of the sheer amount of data. And so the AI can become really smart, kind of per our discussion with the machine learning. And then the behavioral capital, this comes from basically being able to take better advantage of the data, using AI, because we have the data, but we're saying, how does AI help IoT? Well, it's because we can develop this behavioral capital because we better understand our data with AI than simply or strictly through analytical techniques.
Yeah, exactly. Yeah? So that's when we go into the cognitive capital, where AI is very much taking this sort of network and the behavioral effect and then consolidating that into a cognitive capital. Right, so you're making certain decisions, and that gives you the advantage over your competition. So you have gone from behaviors to my decisions and what I'm doing with that, with the people knowledge as well as the sensor knowledge put together.
So cognitive capital, you're saying, is about decision making? Is that that it? Okay,
that's right. Yeah.
And you're saying then the cognitive capital is that you can make better decisions because you can take advantage of your network effect capital and your behavioral capital together. And so it just helps you make better decisions. Okay.
Decisions and outcomes, right? So you're achieving certain outcomes based on those decisions, and that's what the cognitive capital is giving you.
Got it. And what were the first three again? Just to remind everybody of the
so the first
three.
More classical ones are financial capital, human capital.
Oh, right, human
and natural resource capital, right? So basically, natural resources.
Like it. Oh no, I mean, I think that's a good summary of kind of. Because at first, when I was reading it, I didn't get that completely from reading it. But now, if you look at it from a capital, then you say, okay, if the more of this capital that we have, the more competitive advantage we have of our competitors that don't have this same type of capital. And the third one, again, being the cognitive capital, it allows us to make better decisions. But but the reason we're making better decisions is to get, like you said, better outcomes.
Yeah, exactly.
Okay. Well, no, this has been very enjoyable, and I think everybody wants to hear more about where they can read about your report. So maybe just let us know about your report and anything else that PwC is doing that you think our listeners should know about.
Yeah. Now, if you go into pwc.com, you should find a number of areas. So there's one on IoT specifically, IoT and AI. There's a report. We also released a new one under pwc.com. It is the smarter phone. So current phone is, even though we call it smartphone, it's not as smart as it can be. And what we see as the sort of the future of smartphones with all of the AI and the anticipation and all of the things that we just talked about. So that's another report. And then within pwc.com/AI, you can see a number of other reports around artificial intelligence and the size of the market and various use cases of artificial intelligence. So everything under pwc.com, the smarter phone, the AI, and the IoT are probably yes.
Yeah, and everyone, I'll get the exact URLs from Anand, and then you can come to the show notes to get them. But in general, of course, go to the website. You could probably do a search if you wanted to, do a search on IoT. You'd probably get the report. Anything else you want to let us know about?
No. And thank you for the opportunity to talk to you. It's been very interesting.
Yeah, no, it's been my pleasure as well. Thank you.
Thanks.
Okay. That was a good talk with Anand Rao. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Seeing Further into IoT Data with Machine Learning with Vish Pai. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be a symbiotic one.
You have been listening to the IoT Inc. Business Show.